Okay, now we let us look into how to perform the symbolic integration and differentiation using MATLAB. The objectives of this particular program are multifold. First is to introduce you to symbolic integration and differentiation using MATLAB, and perform nth order differentiation of a given function, and triple and triple integrals of the given function under the prescribed limits of integration. You're going to be learning certain simple commands called sims, int, diff, pretty, and double, etc. Sims is basically symbolic computations. It invokes that particular format. Sims XCYV here will always be treated as symbol instead of variables. INT stands for symbolic integration, the same way DIFF stands for symbolic differentiation. Pretty displays the result in a more human readable format. You're going to see what the effect of it in the few lines. Okay. And example, if I want to define the sims as x and y as a symbolic variables, I have to write sims space x space y. Okay, that is one thing. And what if I want to integrate a function like y sine x? Okay, sims x and y, I have to treat this x and y as a symbolic variables, then define my particular function, then integrate int function. Okay, integration variable I am going to with respect to x, and the limits of integration are been chosen as 0 and 1. That is one thing. And that is for the same thing, differentiation, diff, differentiate the function with respect to y. Okay, and prettify all the answers. We're going to see a list of simple examples right now. The first example, I'm going to take integral of integral x dx. So now I have to define sims of sims x and y, and I have to define my I can also do like this itself. Let me define the function. Function is basically x. Okay, I have to define, I have to integrate function with respect to x. Okay, so this is our thing. This has been integrated. If I want to integrate it within the limit 0 and 1, so or I have to provide 0 and 1. Okay, so I get the answer as like this. But if I want limits of integration to be between a and b, I'm going to get an error. Why we are getting an error is we have not defined a and b as our symbolic variables. Now if we go ahead, we actually get b squared by 2 minus a squared by 2. If I going to simplify or pretty ans, I'm going to get an answer like b squared by 2 minus a squared by 2. Okay, that is one thing. We have finished the first three examples, and the fourth one we're going to see integral of integral between a to b, xy dx, xy and dx. Here the integration variable is x. So now what I'm going to do, I'm going to define the integration of what is my function x into y. X into y is the function, and it has to be integrated between a and b. So I get the answer like this. But I can also choose which are the integration variables that I want to use. In this way I'm going to get the same result. It pretty much means that the default integration variable in using MATLAB is x, and I can also choose that to be as y I'm going to get in terms of x, and I can also choose some other random variable like t, in which case I'm going to get minus xy into a minus b. Pretty obvious, right? It's actually xy into b minus a. It's not and like this. And one more thing is, let's go to another example. You can choose different independent variables and integration variables. That is one thing. Now I want to integrate xy with respect to x, and double integration. Okay, problem number 8. Okay, integrate xy dx dy. So how I'm going to do, first is first integral and the second integral. Okay, first integral and second integral. This is the first integral that I have, and the second integral that I have. First integral that I have is going to be xy itself, x into y. That has to be integrated with respect to what? With respect, that is going to be integrated with respect to x. Okay, that is integrated with respect to x. And next one, this answer it will be integrated with respect to y. So the answer is going to be x squared minus squared by 4. Okay. And next problem, we have limits of integration for this particular thing itself. Integration, what are the limits of integration that we have? 1 minus x to 1 minus x squared for the first limits of integration. So this is the first integration that I specify. So these are the arguments for the first integration. This is the first argument, second argument, and the third argument is going to be the lower limit 1 minus x, and the fourth argument is going to be the upper argument 1 minus upper limit 1 minus x squared, and that has been done. And we also seems to have the answer is like this. But the thing is, we also have limits of integration for y variable, in which case it is going to be 0 to 1. This is the second integration. This entire thing from here till here is the first argument of the second integration symbol, second argument for the integration, and third argument is going to be the lower limit, which is 0, and the upper limit is going to be 1. Okay, the answer is like this. Let me simplify this. I can also give pretty of this particular whole thing is going to give me x square x into x minus 1 whole square into x plus 2 divided by 4. Pretty big deal. That is our particular answer that we have right now. That one thing has been finished, and one small thing that we need to do here is integration. I think we have done a slight mistake. Xy with respect to y. Xy I'm going to integrate with respect to y, and then I'm going to integrate with respect to x. So the answer is going to be 1 by 24. Okay, and how do I find out? This is what I meant for double. Double of this is what DOBLE. Double of ANS is this much. Okay, and we have one more thing, one more function, CLC. Let me do it once again. Integration of xy with respect to what? Integration xy dx dy. So but since this has been improperly arranged, so I have to take it as xy dy dx, but because the inner integral is with respect to y. Okay, so now basically what is that? Xy and with respect to y, and what else do we have? What are the limits of integration is 1 minus x and 1 minus x squared. First integral has been obtained. Xy x into y, I need to define it explicitly like this. This has been obtained. So now I have to integrate this once again. This whole thing is going to get integrated with respect to x between the limits of integration a and b. This is our answer. If I want to look at the answer, how it looks like, this is how it looks like. Okay, for continuing on, we also have certain simple examples where integral 0 to 1, integral int, the function is here, and with respect to x, and the limits of integration are 0 and 1, and what is our function defined as? Let me take it as function itself. Okay, function is right now x squared divided by 1 plus x cubed. This is our particular function, and when we integrate this, we're going to find that it is log of 2 by 3. Okay, that has been obtained, done. Okay, and once again, if you want to find out the answer of that, the numerical value, double of the entire thing gives you a numerical value. That is one thing. And let's perform this eighth answer, integral 0 to 1. Okay, so now basically what do we have here? We have our function which has been defined to be like this: exponential of y, exponential of y into exponential of x into sine of into something whole squared. What is that? It's basically sine of x whole squared. This is our particular function. We have defined this. Now what do we have to do? We will have to integrate this function, first with respect to x, with respect to x between the limits 0 and pi, one thing, and we get our answer like this. And once again integrate this entire thing with respect to y, and between the limits of integration 0 and 1. This is our answer. And if I want to find out the actual answer, double of ans gives me the answer 15.21 odd. Okay, that is one thing which is done. Okay, now let us perform some simple differentiation tasks. Basically I have to start with differentiation of x cubed with respect to x. So what I have to do is diff x cubed. Okay, if I don't give anything, let's see what happens. 3x squared, pretty awesome, right? And 10 is going to give you 10x power 9. And further, let us say that if you do specify with respect to which variable you are differentiating, you get the same answer. But however, if I want to choose it as t, I'm going to get a 0, because obviously t is not there in our given expression. There is no t here, so it is not going to work out. So this undefined variable, even though there is t, it is giving undefined variable because I have not defined t as a symbolic variable y and t. Okay, now I'm going to do this x squared, right? This is one thing, and I can also do this with respect to x. I can do this differentiate the double differentiation once with respect to x and the next time with respect to t. Okay, I'm going to get 10x power 9, obviously, right? That is one thing, and we'll go to the next examples. We have x cube plus 4x plus 1 by root of x minus 1 whole cube. So our particular function is, whenever you have a big function, it's better to write it as fun. Okay, function is going to be denominator divided by denominator. Numerator is going to be x cubed, okay, x cubed plus, what do we have here, 4x plus 1. Okay, 4x plus 1. Okay, and what do we have, root of, okay, square root of x minus 1. Okay, this is not going to work because I'm going to have a star in between. I need to put a star also in between there. So now the function has been defined. Now all I have to do is differentiate this particular function with respect to x. So I have to differentiate the function with respect to x, pretty ans. So this is my answer. Okay, this is the answer for the differentiation. Okay, now differentiate sine of x squared, find the third derivative. Okay, we need to find the third derivative for this. Okay, let's do it in 2 steps. Our function is what? Okay, now function is basically okay, now function fun is sine of x squared. This is our function. I need to differentiate this function with respect to x. Okay, and differentiating this, once again differentiate answer with respect to x once again. Now differentiate with respect to x. This is our final answer. Or how many times we have differentiated? We have three differentiations: first differentiation, second differentiation, and the third differentiation. What if there is a way to do all this at once? So diff function is what to be differentiated with respect to x. How many times we need to do it? We need to do it 3 times. Okay, basically we get the same answer 3 times. It has been differentiated and you get the answer there. Okay, that is one thing. Once again, you can also use the pretty command ans here. Okay, that is one thing. And proceeding on, we can also define a particular matrix itself. Let's define A is equals to x and x squared and x cubed and x to the power 7. This is our matrix of A. This is basically a matrix A containing all symbolic values, symbolic variables. I can also differentiate A itself with respect to x. Okay, entire matrix is going to be getting this differentiated. Let me check pretty on this one. I don't know. Yeah, it does work. Okay, it does give me a prettified answer for the matrix as well. That is one thing. Next, proceeding on, let us find out this particular differentiation. A function is equals to x y z, x plus y plus z. This is divided by x plus y plus z. So basically, we need to create a triple differentiation of the particular function with respect to x, with respect to y, with respect to z. So first we have to define our particular function. Particular function is given by x into y into z divided by x plus y plus z. This is our function variable. Why we're going to get it? We are not defined it as symbolic variable, symbolic x, y, and z. And then now we have the particular function there. Now basically have to define differentiation of the function with respect to x. Right, this is going to get differentiated with respect to y, and this is going to get differentiated with respect to z. Okay, so answer is like this. Pretty ans is this much. Okay, now CLC, I'm going to do the same stuff once again, and function has been defined. Oops, I did not want this to happen. Sims has been done and function has also been defined. All we have to do is integration. Let me put this function as answer is equals to this much. This is our answer. Okay, so now we need to evaluate this at x is equals to 1, y is equals to 1, and z is equals to 1. So basically you need to create a function function is equals to inline ANSER. Okay, answer, we have created an inline function for FUNC. Okay, FUNCT. I have to evaluate this function eval. Which function I am going to evaluate? FUNCT. Okay, this is the function that I have created using the inline function. I have created the inline function for the answer. Okay, that is stored in FUNCT. So I'm going to call this function. Whenever I call this function FUNCT, this actually is referring to this ANS answer. Okay, if function evaluate this expression at the values of what values? At value of x, y and z, whatever order is mentioned here, whatever values I give, that will be taken in the same order as this x, y and z. Okay, so what do we have here? X is 1, y is 1 and z is also 1. So I'm going to give 1, 1 and 1. I'm going to get an answer like this. So this is the solution to our particular thing. And what about the second one? Our function is actually defined as 1 by x by z, 1 by x by y by z. This is our function, and we need to differentiate twice with respect to z, and then differentiate it once with respect to y, and then again with respect to x. Okay, so differentiation of the function. Okay, first with respect to what? First with respect to z. But how many times? 2 times. So I'm going to write this here. This once again is going to get differentiated with respect to y. Okay, and this once again is going to get differentiated with respect to x. Okay, and we also have to evaluate the answer. Evaluate this at x equals 1, y equals and z is equals to 1. I'm going to write that answer is equals to this, the function, or I'm going to come up with a better name for this so that you can remember. Function FUN function for answer will be inline answer. This has been created. So now function evaluate function for answer at 1, 1, 1. This is the result. Answer is 2. Okay, so I hope you have learned differentiation and integration. Now I think you can solve pretty much most of the problems which have been provided in your CLA MATLAB manual. If in case you have any doubts, you can always mail it to sunilanandtirtha@pes.edu. and okay, this is one thing. Please do mail this to me in case you have any doubts so that I can reply it back to you. And all the best for your exams.